Hi students, myself Channakeshwar Rao. I am from Physics department. So today onwards we are going to start first PU Physics lessons. So before going to that, all of you have chosen our college. You came to know, you heard about our college. Therefore, I am thinking you have chosen. You will be having so many aims, targets. Some people will be having to go for JEE mains. Some people may go for NEET. Some people aim good college for CET engineering. You may choose. So especially who are going to join in NEET, only I want NEET means they can read mainly physics, chemistry, so biology. Who are going for NEET? Who are aiming for mains? Mainly they have to read physics, chemistry and maths. Who will be going for CET? CET means they can read all PC, MB, competitive. I am saying once again, who wanted to go for NEET, especially they have to concentrate more on biology, chemistry, physics. Mains, physics, chemistry, mathematics. CET means both you have to read. Okay. Next, some of you may come from Kannada medium. Okay. So especially who came from Kannada medium in 10th class, they may face little bit difficulty for first 6 months or 3 months or 4 months. So you people, what you have to do means, who came from Kannada medium, you have to learn the words which is related to English. Let us assume in Kannada Dora, Dora is. So Dora means in English we will say distance. Okay, Sthanabhramsa irutte. Sthanabhramsa andre in English we will say displacement, mass. Okay, all these words you should come to know from Kannada medium to English medium. Those words you have to practice. First 3 months you may face little bit difficulty, but after 3 months it will become easy. Okay. Now we are going to start first PU, one lesson, motion in a straight line. So before going to start that lesson, before going to go for physics subject, so can anybody recall once, because all of you are at home, once you can recall what is meant by physics. Some people may face difficulty in physics. So physics is difficult subject they may feel. But actually among all subjects, physics only easy subject. Why we will feel difficult means we don't know fundamentals or basics. What are those fundamentals? What are those basics? In which course sir might have explained for you for only one lesson, motion. So we didn't have time to recall remaining lessons. Therefore we are starting. Before going to start that lesson, we will give basics or fundamentals also related to that lesson. So once recall your 9th class textbook, you will get some of the lessons for first PU. If you recall 10th class textbook, that one will be going for second PU lessons. So what is meant by physics? So what is meant by physics means here, this one. You may say some definition, it is branch of science, something definition you will say like that. But among all those, in simple way, to study nature. So study of nature is nothing but physics. Whatever lesson, whatever topic we have taken, that will be going in the physics. That one we are going to learn within the textbook. That one we are going to write within the exam. So simply study of nature. What will be going in nature? Let us assume sir explained about motion. If you are moving from one place to another place, is that going in nature? So in nature it is going. So about that one we are studying. There we got two concepts. One is distance, another one is displacement. Isn't it? Is it going in nature? Later some uniform motion, non-uniform motion. Already all these you will be getting in our nature, but that one we are going to study. But no one will be coming to know that we are studying nature. So this is the definition of physics. Study of nature. In that all these lessons all these topics will be coming, and we have to apply those in our daily life. How we are going to apply means, if you move from your home to somewhere, then how much distance you cover? How much distance you covered, if you calculate means, that is only study of nature. You covered distance and you covered some amount of displacement. If you apply this one daily, then it is going to become easy. Okay, so study of nature is nothing but physics. Now we will see our first lesson, not first lesson, third lesson in this, but we are going to start this one because you came to know about motion. Already we gave some basics on this. Motion in a straight line. So motion in a straight line. In the name only it is there. So object is, motion means object is changing its position with respect to time and surroundings. I will give definition also. In a straight line. So object is moving in a straight line without going any direction, only in one direction, particular direction it is going. So when the object is said to be in motion, when the object is said to be at rest. First we will go for rest. So when the object is said to be at rest position. When the object is said to be in motion. So first we will see rest. For this we require one reference point. Reference point. So what is this reference point means? In your home only, in our classroom only, we can take this reference point. How we will take this reference point? So object is said to be at rest position. To say object whether it is at rest or in motion, we will take by taking one reference point. Now if you have taken me, I am in college classroom, I am in front of the board. Now board is the reference point for me. Now I am in front of the board, I am not moving anywhere with respect to time and surroundings. Then I will be at rest position. Now all of you are sitting at home, you are seeing the video. Then you will be at rest position with respect to your home. Your home is the reference point. But physically we can't say home and classroom is reference point in physics. For this one definition they will give. How they will give means, they will take one coordinate axis. Coordinate axis means they will take x-axis, y-axis, z-axis. Let us assume the coordinate system, x-axis, y-axis, z-axis. The z-axis will be coming like this. Okay, we can't draw this one on the board like this, therefore we will show like this. So this is coordinate system, three axes we have taken, x, y, z, mutually perpendicular to each other. All are 90 degrees. So this is z-axis, so this is y-axis, this will become x-axis. So x, y, z. This point of intersection we are calling it as a reference point. So in our room, if you have taken corner you can take it as a reference point. Otherwise, you can take this wall as reference point. Okay. If you have taken corner as reference point, coordinate system, then origin. So where those are three axes are meeting, one wall, second wall, third wall, ceiling and all, floor, this wall and that wall. Where those are going to meet, that is nothing but reference point. So for this reference point O, for this coordinate system, if we attach one clock, we attach one clock. Clock means here time. Okay, what we attach. Then this one only we are calling it as frame of reference. Frame of reference. Okay, the coordinate system which is having clock is called frame of reference. Why we require these two? Why we require means whether object is either at rest or motion, we require either reference point or frame of reference. Frame of reference means it is physical world, but in our nature, if you have taken a classroom with one clock, I will be having watch. So this classroom we can call it as frame of reference. We are going in a train, one compartment you will be having watch. Then compartment is one of the frame of reference. Principals or chamber is there with wall clock. Okay, principals or chamber we are calling it as frame of reference. Your home, one of the room is having wall clock. So your room with wall clock we are calling it as frame of reference. So reference point, frame of reference. With respect to these, we are going to say whether object is at rest or in motion. Okay. Now within this frame of reference, with respect to this frame of reference means so coordinate axis with respect to clock. So now it is whenever I started video, so it is time 11 o'clock, let us assume. So at 11 o'clock you will be in front of this board. At 11:15 you will be in front of the board. At 11:30 you will be in front of the board. In front of the board means I am taking it as a reference point. So at different points your position is not changing. At the time we are calling it as object is said to be at rest position. With respect to time, object is not changing. Another one will be there. With respect to surroundings. With respect to surroundings means where you are with respect to that reference point, that frame of reference, you will be at same position. Now you are in the compartment of train. You are not moving. Then you will be at rest position. Your train is moving. Then you are in motion with respect to the person who will be on the platform. Okay, that reference point and frame of reference is very important. Okay, in that railway compartment, train is moving. Whenever train is moving, you will be in motion with respect to the person who will be at rest position on the platform. Okay, so that one you have to see carefully. Now you will be at rest position whenever your position is not changing with respect to time and surroundings. Okay, understood all of it. The position of the object is not changing with respect to time and surroundings. So that is called, then object is said to be at rest position. When it is said to be in motion, when it is said to be in motion means when object position is changing with respect to time and surroundings. Object position is changing with respect to time and surroundings. That is called, then object is said to be in motion. If the object is said to be in motion, its position and its position is changing with respect to time and surroundings. So if position is not changing with respect to time and surroundings, then the object is said to be at rest position. If the position is changing with respect to time and surroundings, then object is in motion. Now all of you are watching video by sitting at your home. So you will be at rest position with respect to home. Okay. If you are moving after starting college, if you are coming from college, then your position is changing with respect to time. Therefore, you will be in motion. Okay, this is about rest and motion. So now we will see this one we gave reference point, frame of reference. This frame of reference always won't be like x-axis, y-axis, z-axis. It will be depending on how the object is moving. If object is moving on a straight line means one single wire if you are taking. One single wire, a small ant is moving on this wire. So ant is moving on this wire only on wire, it is having only one direction. Therefore, this is nothing but 1D levels. 1D or one dimensional or along x-axis or along y-axis or along z-axis. This axis may be anything. For let us assume convenience, we will take only x-axis. In our simple long ways, for simple and you can understand very easily. So therefore we will take along x-axis. Ant is moving along the x-axis means only in one direction because this is white. Now we left this ant on the table. This is nothing but table. Let us say table surface. Then this ant can move in two directions. One is either along x-axis or along y-axis. You may say this is also another way now. Okay, this is another way, but we can define this way in two ways, either along x-axis or y-axis. This one we will call two dimensions. At that time, reference frame you have to take along x-axis and y-axis. For this reference frame is only along x-axis, any one axis, either x, y, z. For our convenience, we will take only along x-axis. This one we can take this one along x-axis, this one along y-axis. Otherwise y-axis, z-axis. Otherwise z-axis, x-axis. This table you can take it as given. Another one will be cube. So three dimensions. So if you have taken cube, if you leave this ant here, this can go in three ways: x-axis, y-axis, z-axis. So how it is moving? Depending on that motion of the object, we are saying it as reference frame. How we have to take? That may be single line, that may be 2 lines we will take, that may be 3 dimensional or 3 lines we will take. Another one, here object we will take, always we will say point object. What is meant by point object? The object which is having point, that is not point object. Okay, not according to name. Sometimes we can call object as point object, sometimes we can't call same object as point object. When we can call object as point object, when we can call object is not a point. When we can call means in very simple way, object size is smaller than distance covered by the object. Still I will give what is meant by distance, but generally you came to know distance. I will give the definition for this. Okay, size of the object is smaller than the distance covered by the object, then the object is said to be point. This is the definition in physics. But how we can remember this one means, let us assume I moved from here to there, this end to that end, board this end to board that end. Otherwise, you moved in your room from one corner to another corner. Then your size is not point object. Means you should not call you as a point object. You cannot call me as a point object. Why? Because compared to height of mine, I covered very small distance. If I cover from some Bangalore to Kolar, so Bangalore to Kolar is 70 kilometers. Some 60 kilometers distance. At the time you cover little bit more distance compared to your height, compared to your width. At the time you will become a point object. So point object is, when we are saying means, compared to the size of the object, distance covered by the object should be more. Otherwise, compared to the size of the object should be small. Compared by the distance covered by the object. If you have taken train is moving from Kolar to Bangalore. Kolar to Bangalore, train is moving means we can't call that as point object because that is less distance. So from one state to another state, train is moving, not border, from one state center to another state center. Then it is covering 1000 kilometers. Then we are calling it as train as point object. Now we understood what is meant by point object. I may ask this one after second lesson started. Therefore, remember this one. Point object. Size of the object is smaller than the distance covered by the object. Then the object is said to be point object. Okay. So in our lesson only we are discussing straight line. Now we understood what is meant by motion. So object position is changing with respect to time and surroundings. Then the object is said to be in motion. So motion in a straight line. So what is meant by straight line? Straight line means any line you can draw. If object is moving in a straight line path, linear path, that one we are calling it as rectilinear motion. This one only we are calling it as straight line motion. Object is moving in a straight line path or linear path. Rectilinear motion we say. Now, rectilinear motion is it going only in one direction or two directions? It is having two directions. One is in forward, another one may be in backward. Both are a straight line motion. So now we are going to discuss in this lesson either object will move forward or backward. Whenever object is moving forward, whenever object is moving backward, what is the distance, what is the displacement, what is the velocity, what is the speed, what is the average velocity, what is the average speed, and what is the instantaneous velocity, instantaneous speed, and acceleration. About all these we are going to discuss in this lesson. Okay. Now we are going to path length or distance and displacement. This is the original lesson. From here on onwards, important points, important definitions, important questions will be coming. So before going to start this distance and displacement, whoever taught for you, they will teach according to the textbook. So first we have to listen, we have to apply that one carefully, then everything will become easy for you. Okay, you have to listen carefully and you have to apply carefully. Okay, now what is meant by path length, what is meant by distance? Generally, if you move from one place to another place, we will say you cover some amount of distance or you cover some amount of displacement. When we have to say it is the distance, when we have to say it is the displacement. And sometimes both the distance and displacement will be equal. Sometimes it may not be equal. Where those are going to be equal, where those are not going to be equal, we are going to see. Once you understood all these, whenever you are applying, you will be getting. Then only understood. Otherwise, simply what is there, book definition, what I wrote here, what you wrote in notebook, those will be there. So you have to apply this after knowing the definition. Now path length, and the name only is there. Path length. You moved from home to college. Home to college means you cover some amount of length. Length will be there from your home to college. That is only we are calling it as path length or distance. The total path covered by the object, the total path covered by the object from initial point to final point. This is the general definition of the distance or path length. The total path covered by the object. Your object may be you or someone or anything. You can take bus or car or lorry. So you can take anything. So the total path covered by the object from initial point to final point or from initial position to final position. That is nothing but definition of the distance. Next, what is meant by displacement? Again, from this initial point, final point will be there. If you have seen distance means, so you started from home, you came to college. So your initial point is, initial position is home, final position is college. So you cover some amount of length. So the total path covered by the object between initial position and final position. That is called distance. Now what is meant by displacement? What is meant by displacement means the shortest possible path or the minimum path. The shortest possible path, we will say simply shortcut. Shortest possible path between initial point and final point. Here shortest possible path also this one. Home to college. Let us assume home to college is just 5 kilometers. Now you covered how much distance means 5 kilometers. How much displacement you covered means that is also 5 kilometers. Okay. Now one person is coming like this, home to college. So he started at H, some point home, A, is going to B, C, finally at point D college is there. Okay, you came like this. At the time, this is 5 kilometers, this is 2 kilometers, let us assume, this is 2 kilometers. Now, he started initial point at A. Final point at D. Now what is the distance covered by the person? What is the displacement covered by the person? According to definition, the total path covered by the person or object between initial position and final position. Total path means here A to B, B to C, and again he came from C to D. So total path how much now? AB. That is nothing but 2 plus 5 plus 2. So 2 plus 5 plus 2. How much? So 2 plus 5, 7. 7 plus 2, 9. Now total distance is how much now? 9 kilometers. Next we will see. What is the displacement? According to definition, what is the displacement definition? The shortest possible path or the minimum path between initial position and final position. Here what is the initial position? A. That is nothing but 1. What is the final position? D. Now what is the shortest possible path? This one. The shortest possible path or the minimum path is home to college is this one. Therefore, displacement how much now? 5 kilometers. Now you can see one point. Here distance is nothing but we said total path covered by the object according to definition. Okay, according to displacement definition, the shortest possible path or the minimum path between initial and final. Okay, so after some time, after college is completed, again he will come to home. Directly he came, otherwise A, B, C, D, again he is coming from college to home. So he started initial point is home, again he is reaching final point is also home. At the time, what is the total distance he covered means 2 plus 5 plus 2 plus 5. So total 14 you will be getting. 2 plus 2 4, 5 plus 5 10. 14 kilometers is the total distance. So another one, displacement. What is the displacement means? Home to home, initial point, final point. Shortest possible distance between home to home is 0. Therefore, you will be getting total displacement 0 kilometers. So this is about distance displacement concept and the definition. What is the definition for distance? We said the total path covered by the object between initial and final position. So displacement means the shortest possible path between initial and final position. That is the distance displacement definitions. You have to apply these whenever you are moving from home to some shop also you can apply. How we can apply, sir? We don't have scale, we don't have measurement means, you don't need to do anything. You can take 1 foot is nothing but 1 step is nothing but 1 meter you can measure. How many steps you covered? How many steps you covered? Those steps into 1 meter you can count. You will be getting distance. After reaching your home, again your displacement is 0. Total distance means how much distance you got from home to college, college to home to shop, shop to home. You can count. If you apply this one 2 to 3 times, you will be getting idea on this distance and displacement. You won't forget if I ask you to forget also. Okay, so this is about distance displacement. But we said here only in a straight line path. Whenever it is going in a straight line path, we are going to see here object should move either in forward direction or backward direction. Now object or person is starting from origin at some point. So this is 1, 2, 3, 4, 5, 6, 7. So object starts, person is starting from origin. So he covers some amount of distance or displacement in some time. Now he is at 4. Rather this one you can take it as either meter or centimeter. Still I didn't give the units, I will give the units. Just I am going to ask what is the distance, what is the displacement, whether you understood or not, I will be getting from here. Let us use meters you can. Now person is moving from O to 4. This point you can take it as A. Origin is O. Now what is the distance covered means? Distance from O to A is nothing but 4 meters. What is the displacement? O to A. How much you got displacement? That is also 4 meters. Displacement 4 meters. Distance also 4 meters. So this is initial point. This is final point. Now we covered O to A and A to from where he came. He came back. First he went like this. Again he came. Now what is the distance covered by the person? This letter is B. 4. Now say what is the distance according to definition? The total path covered by the object. What is the total path covered means? From O to A. O to A how much we got? 4. Again from A to B. A to B how much he covered? How much you got this distance? This is nothing but 2. Therefore, 4 plus 2. Total how much? 6 meters. Next. 6 meters only, that is nothing but distance. Now displacement. So what is the displacement? You see here OB, we wrote directly here. O to A is covering. Next is coming from A to B. Now drawing here. Now O to A how much we got? O to A is 4, OA. Now A to B is moving from 4 to 2. So how much line this is? This is path line. 4 to 2 means how much? 2. So total is 6 meters. This is nothing but distance. Now we are going to see displacement. What is the displacement means? Definition. The shortest possible distance. Shortest possible distance. Shortcut from O to B. This is the shortest possible distance between OB. That is nothing but 2 meters. Okay. So once object is moving in a straight line path. Now this is straight line path. So distance and displacement. How we have to write. Now by seeing this one. So by seeing this one or by seeing this one, we can get one point. What is that one means? Distance. Sometimes distance displacements are equal. Sometimes distance is greater than displacement. Isn't it? Distance is equal to displacement. Distance is equal to displacement. Sometimes we are getting distance is greater than displacement. Correct only? I wrote according to this one. Just one example. You can take any example, you will be getting like this one. Okay. So distance sometimes is equal to displacement. Distance sometimes greater than displacement. Now see here, distance is equal to displacement. Distance is greater than displacement. When distance is equal to displacement, we will see. If object is moving continuously without going backward, object is moving straight in straight way direction without moving backwards. So object is moving in a straight line path without going backwards, without turning backwards. At that time, distance is equal to displacement. Now you cover 5 kilometers, displacement also 5 kilometers. Then we have to understand object is not moving backwards. So some person cover 10 kilometers. This distance displacements will be same. Then we have to understand that object is not moved backwards. Object is moving only in forward direction and only in one direction. That one you have to understand by seeing this one. Very simple. At 0 to 1. What is the distance? 1 kilometer or 1 meter. Displacement also 1 meter. 0 to 5. Distance 5 meters. Displacement 5 meters. Later is moving 5 to 6, 6 to 7. Like that he is moving continuously in forward direction. Then distance is equal to displacement. So if he is moving backwards, then we have to understand distance is always greater than displacement. By combining these two, they will write like this. Distance is always greater than or equal to displacement. In some competitive exams also, they will ask this question: what is the ratio between distance and displacement? They will ask. That is equal to greater than or equal to 1. If ratio is reversed means displacement by distance. At that time, this will become less than or equal to 1. Which one they are asking? You have to see the question carefully. Distance by displacement or displacement by distance. Distance by displacement means greater than or equal to 1. Displacement by distance means you will be getting here less than or equal to 1. Understood? Now, what are the differences between distance and displacement units, and what is the symbol? Whenever you are representing, how you will represent distance and displacement? I wrote here, whenever I am writing OB, I said distance. Here OB, I said displacement. Without saying that one, by seeing that one, whether they are asking distance or displacement, we can say. How we will say means very simple. So is it vector or scalar? What is meant by physical quantity first? Physical, actually you will be having one lesson, vectors and scalars. There you will be getting, but here we want whether distance is vector or scalar. To know that one, from basics also you should come to know. What is physical quantity? What is physical quantity means? Any quantity that can be measured. Any quantity that can be measured. That is called physical quantity. You will be having so many physical quantities. You can take mass. Mass can be measured. Therefore, mass is a physical quantity. But you don't know that is physical quantity or not. Distance we can measure. Displacement we can measure. Time we can measure. We can take any symbol or any quantity you can take, that one will be coming under physical quantity. Mass, velocity, acceleration, speed, all these will be coming under physical quantity. But you know, till now only two physical quantities, that is nothing but distance and displacement. Now, among these two physical quantities, these physical quantities can be divided into two ways. One is nothing but scalar, another one is nothing but vector. Okay, what is meant by scalar? What is meant by vector? I think you came to know up to 10th class. Scalar means the physical quantity which is having magnitude and only magnitude. Vector means both magnitude and direction. For this another one also will be there. It should obey laws of vector. Vector laws there is. Vector laws. The physical quantity said to be scalar means it should have only magnitude. The physical quantity which is having only magnitude is called scalar. The physical quantity which is having both magnitude, direction and which is obeying laws of vector, that is called, that physical quantity we will be calling it as vector. But presently we will be coming to know only magnitude and direction. Sometimes it will be coming, but according to definition you have to see laws of vectors. Okay. It will be coming in second year clearly, because whenever we are saying current will be having magnitude and direction. In your 10th class current you got, but current is a scalar quantity, right? Because it will not obey vector laws. But presently we need to know, we should come to know what is distance, what is displacement. Not definition, scalar or vector. Now you told for me your home is distance from here to your home is let us assume 5 kilometers. Then can I come to your home? Means I can't. Why? Because you should give for me particular direction. From here to how I should go, from there to how I should go. So here to Kolar to Bangalore, we will say 70 kilometers. 70 kilometers in which direction? To get displacement, what we require means direction is required. Therefore, now among these two, distance and displacement, which is having only magnitude means distance. Distance is having only magnitude, but displacement is having both magnitude and direction. So magnitude and direction. Why? Because if it didn't say direction, I can't come. I can't come means I can't displace from here to there. So therefore we are calling displacement is a vector quantity, distance is a scalar quantity. So whenever you are representing D, if you wrote, that is called distance. Whenever you are representing displacement, how you will keep means one bar will be writing D bar. Now whenever we are representing D, we are writing distance. Whenever we are representing bar, that is representing displacement. Now came to, once you can see here, OB, what is OB here? We said distance, therefore bar is not required. So OB is here displacement, therefore bar is there. So the OB indicates distance, OB bar indicates displacement. If we didn't draw bar in our first B, so that is wrong. You gave distance if you didn't write bar. Now you came to know which is vector, which is scalar. Here OA is distance, OA bar. Here in this case both will be same. So whenever distance is equal to displacement, we will write now magnitude of distance, magnitude of displacement. Both will be same whenever object is moving in a straight line path. These are symbols of distance and displacement. Now you got one difference. That is nothing but distance is nothing but which quantity? Scalar quantity. Why? Because it is not having direction. Next, displacement is nothing but vector quantity because it is having direction. And what are the units? Units of distance, displacement. In physics language means you will be having English, Kannada, Hindi language, Sanskrit. So physics also one of the language. You have to speak with units. In mathematics, whenever you are solving, simply will write answer 10, 5, 0 like. But in physics, you have to write with units. If you didn't write units, you are going to lose 1 or 2 marks depending on the problem. So distance units, so meters, centimeters, kilometers. So generally always we should do problems in MK system. Therefore everyone whatever they are giving uniformly they will follow MK system or SI system. We will say meters only. In meters only how to solve the problems. If they give centimeters also we should convert. Okay. Already bridge course we give what is 1 meter value, centimeter value, how to convert. You should convert those carefully. Now displacement is also same. But mainly whenever we are solving problems, we should solve and substitute with meters only. If they give kilometers also, we should convert into meters. That is the fundamental property whenever we are doing physics problems. Now both the units will be same. Now we got another point. Unit is meter. Both will be same. One difference we got. Distance is a scalar quantity. Displacement is a vector quantity. So is it there any other difference? Any other difference means, yes, distance you got 0. So distance we didn't get 0. Distance is having some value. Displacement will be 0. Sometimes we are getting displacement 0. Here one case you got. So displacement is 0, but we can't get distance as 0, isn't it? Unless and until you move. If you are at home only means your distance and displacement will be 0. Once you move, then distance will not become 0, but displacement can be 0. Now another question I am giving for you. Now we got distance cannot be 0, displacement can be 0. That is also one of the difference. Now I am giving distance can be negative. Can it be negative? Negative value you will get. I covered minus 2 kilometers distance. Have you ever said? You can't say I covered minus 2 kilometers distance. Therefore, distance cannot be negative. Distance cannot be 0. Distance cannot be negative. I am saying unless and until you move. Once you move, then distance cannot be 0 and distance cannot be negative. Then what about displacement? So can the displacement will be negative? Can we get negative displacement? Once again, think, can we get negative displacement or not? Okay. So now we will see, can we get displacement negative or not? Okay, among all this we did so many problems. So displacement according to equation, if you want to write delta x means change in position. Here delta refers change in position. Here position along x-axis, therefore we wrote delta x. If it is moving along y-axis, only y-axis, then we will write delta y. Delta x is equal to final position minus initial position. That one we will write xf minus xi, or we will write for two positions, 2 points, x2 minus x1. This is nothing but if bar is there, that is called displacement. If bar is not there, that is only called distance. But distance cannot be negative. Now we will see displacement will be negative or not. Here I wrote distance, is it negative or not? That's all. So distance cannot be negative. Now you will see displacement. For this I gave one example there. Same example. O to A here. Next we move from A to B. So whenever is moving from 4 to 3, A to B. So what is the initial position here? A. Final position, how much? 3. Otherwise 2 also you can take. There I think I took 2. Therefore you can take this B here. Okay. So initial position is moving whenever is moving from A to B I am saying. So at A, what is the initial position means? Here to here distance, that is nothing but x1. What is the final position? Whenever we move from A to B, final position is B, that is nothing but x2. So x2 minus final position minus initial position. Final position is 2. Initial position is 4. 2 minus 4. How much you get? So minus 2. So here minus is indicating direction is going to be reversed. So magnitude, according to magnitude it will be same 2 only. But why we are writing here negative? This negative side indicates person is moving not in forward direction, he is moving in backward direction along this direction. Once he started this direction, this minus is indicating a person is moving in backward direction. Now you got displacement can be negative or not. So you will get displacement sometimes negative, but distance cannot be negative. What is the distance covered between A to B now? Final position minus initial position. Then you should take 2 meters. 2 meters is the distance. Delta x 2 meters. This is indicating distance. Delta x this bar gives it is having direction. This is nothing but displacement. So this minus is giving negative direction. Negative direction means opposite direction. Understood? Now displacement can be negative. Distance cannot be negative. Now you got differences. What is the first difference means? Definition only always first difference. What is the definition of distance? The total path covered by the object between initial and final position. Next, displacement, the shortest possible distance between initial and final position. Next, distance is a which quantity? Scalar quantity. Displacement is a vector quantity. Now, distance can be always positive. but displacement can be positive, negative, 0. Another difference also you can write. Distance cannot be 0, displacement can be 0. Sometimes it will be 0. These are the nothing but differences. Okay. So now we will see, this is motion in a straight line. This example I gave here, this example in your textbook they gave in different way. Once you can take whenever object is moving from P to Q, Q to Y, Q to R somewhere. Once you can check now how much is the distance, how much is the displacement. After seeing this video, then you will be getting whether you understood or not. You should be in a position to solve the problem. Okay, they will give on straight line like this, they will give negative values also. This thing. Okay, we will do that one later. Only positive side we can do. Now we got just positions you have to take, then final position minus initial position. So we are in motion in straight line lesson. Now I am going to give one small tricky question for you. If object is moving in circular path of radius r, object moves in a circular path of radius r, then for one complete revolution, for one complete rotation, what is the distance, what is the displacement? They may ask for competitive purpose, not for P. What is the distance means? Circumference of the circle gives distance. Okay, what is the circumference of the circle? 2 pi r. All of us will be coming. What is the displacement? So shortest possible distance between initial and final position. Therefore, both will become 0. So this one very easy one. If he is going to cover half of the circle, semicircle. Semicircle means he is moving from A to B. What is the distance? What is the distance means? DAB is equal to total path covered. So total for one circular path 2 pi r. For semicircle, how much will get? 2 pi r by, that is nothing but pi r. This is nothing but distance covered by the. Now person is moving from A to B. So it is semicircle. Semicircle is only is covering half of the circle. Half of the circle means total distance is 2 pi r. Then half of the distance is DAB is equal to total distance within that half. Then that is nothing but pi r. Next, what is the displacement? Displacement means you have to give one bar. DAB bar is equal to, what is the displacement definition? The shortest possible distance. The shortest possible distance between initial and final. This is the shortcut, shortest possible distance. So from center to here r, this center to here, therefore total displacement is r plus r to r. This is nothing but for semicircle. Understood? So always we are taking semicircle, 1/4 full circle. Then if they have given in this circular path, he is moving from only some amount of arc length between A and B. Then what is the distance covered by the person? What is the displacement covered by the person? These two won't be there in your PU. This is only for competitive purpose. Why I am giving means, now only we discussed about distance and displacement. Therefore I am giving, he is moving from A to B. So what is the distance between A and B? What is the displacement between A and B? First we will see distance. So it is making some angle theta here. This radius is r. So you will be having this angle definition. Theta definition you are 8th, 9th somewhere in mathematics geometry. So what is the definition means? Angle theta is equal to arc length by radius. Here arc length is nothing but AB. That is nothing but D or L they will write. So D AB by radius is nothing but R. This is nothing but angle theta. Then DAB is equal to theta R. This is nothing but distance formula between one point to another point whenever it is making some angle theta. So once you can check with full circle. Whenever it is completing full circle, what is the angle made by the person means 360 degrees. 360 degrees we can write it as 2 pi. So theta is 360 degrees. 2 pi into r. You got for half circle. Half circle theta how much? Theta is 180. 180 means pi. So theta value is pi into r pi. This is nothing but general formula for distance. Now we will see general formula for displacement. What is the displacement definition? The shortest possible distance between A and B. A and B means we have to draw one shortcut. This is nothing but A to B. A to B from A to B directly. That is nothing but shortest possible distance. Now AB, DAB bar, we should find. That is nothing but AB bar is equal to, we will see. We are going to divide this one into 2. Whenever we are drawing one bisector here, this theta will become theta by 2. This theta will become theta by 2. This is nothing but point assume C. Now AB bar is equal to, or AB is equal to AC plus CB. This is nothing but displacement. What is AC? What is BC? We should find. This AC is opposite side for theta by 2. This BC is opposite side for theta by 2. Therefore, which trigonometric function we will see means sin theta. What is sin theta definition? Here theta by 2 is there, therefore we wrote sin theta by 2. What is sin theta definition? Opposite side by hypotenuse. Here theta by 2 opposite side is AC. AC by hypotenuse is OA, isn't it? Therefore AC is equal to R sin theta by 2. You got AC. Now we should get CB. What is CB? Again, sin theta by 2 we should take. Sin theta by 2. Opposite side from this theta by 2. That is nothing but BC. BC by hypotenuse is R. Then BC is equal to R sin theta. Substitute here. So R sin theta by 2 plus R sin theta by 2. Then DAB bar is equal to R sin theta by 2 plus R sin theta. So 2R sin theta by 2. This is the formula for displacement between any two points. Derivation is not required for you. So distance means theta R. Displacement means 2R sin theta by 2. If you know theta and R, you will be getting distance or displacement. See what? For full circle. For full circle theta is how much? 360 degrees. 360 by 2. 180. Sin 180. Sin 180 value, how much it should come to? That is going to become 0. Therefore, displacement is 0. So, for half circle theta how much here? 180. So, substitute here. Sin 180 by 2. Sin 90. Sin 90 value how much? 1. Therefore, 2R. Therefore, if you know angle and R, you will be getting distance or displacement. So, these are the important formulas for competitive purpose. They won't ask in PU. Okay.